For number 8, we're looking at the relationship between drinking colas and to see if that has an effect on the bone density of women. So we have a table of data here, and we're going to open it in StatCrunch. And the first thing we want to do is find our least squares regression line. So go to simple linear there, and our explanatory variable is the number of colas that someone drinks, and we want to see how it affects their bone density. And when we hit compute, we get the least squares regression equation right here at the top, and it's actually writing out x and y in words of what they are. So this right here is the y, the bone density is equal to, and then it gives us our numbers in the least squared regression line. And notice that this number right here is the one that's multiplied by x, and it actually wraps down to a separate line. If I make the window a little bit larger, you can see that our x, the colas per week, comes up there and is multiplied by that number. So make sure you enter these numbers correctly. Back in StatLab, that is the number that goes next to x. And so round to the proper decimal spot as needed. And the way we interpret slope is always the same. It's how much does y change, which in this case is bone density, for every increase in x by 1. And x in this case is colas. So for every cola consumed per week, that goes up by 1, the bone density is going to change by the slope amount, which in this case is a decrease because it's negative, and this is the amount of the decrease. And then to interpret the y-intercept, that's the value for our y variable, which in this case is bone density, when x is equal to 0. X in this case is colas, so it would mean if we drink 0 colas in the week, what do we assume the bone density will be? So this is our y-intercept. That would be the bone density if someone drinks 0 colas for the week. For D, we're going to predict the bone mineral density for someone drinking 4 colas per week. So we're just going to plug 4 into our equation here. And so put 4 into the least squares regression line equation, and when you calculate what that would be, this is your result, and that would be our prediction then for the bone density of someone drinking 4 colas a week. The next part is saying that someone found a woman who actually did drink 4 colas a week, and they had this bone density. And we want to know if that is above or below average for women who drink 4 colas a week. Well, our prediction from the least squares regression line is what we assume the average is for women who drink 4 colas a week. So if this particular woman has a bone density that's less than our result from the least squares regression line, that means this person is less than the average or below average for drinking 4 colas a week. And our final question is, would you recommend using this model here, our least squares regression model, to predict the bone mineral density of a woman who drinks 2 colas per day? So notice it's per day. You need to translate that into per week. 2 a day would be 14 a week. And if you look at our data here, there's no one even close to 14 a week. So that's way outside of the scope of the data. And so an x value of 14, that's outside the scope of our model, so we should not use our model to predict bone density for someone who drinks 14 colas a week. Number 9, we're looking at the correlation here between how many days a student is absent and their final exam score is our response variable y. So we have our data. We're going to want to open that in StatCrunch. And we're going to use StatCrunch to find the least squared regression line. And our explanatory variable x was the number of absences, and the final exam score is our response. When you hit compute, you get your least squared regression line right here at the top. And notice that the y-intercept is listed first, and then the slope that's multiplied by x is listed second. So round those to the correct number of places, and that is your least squared regression line. And now we're going to interpret the slope and the y-intercept. This interpretation of slope is how much does y change when x changes by 1. So when the number of days absence changes by 1, how much will the final exam score change? And it looks like it's going down because our slope is negative, and it's going down by this many points for every additional day that a student misses class. And then for the y-intercept, that is what's the y value when x is equal to 0. And so in this interpretation, it would be x being 0 would mean the student misses 0 classes, no classes at all. And so their final exam grade would be this on average. This is our y-intercept. We use least squares regression lines to make predictions, and that's what we're doing in part C. We're going to use this line here to predict the final exam score for a student who misses 5 class periods. So you're going to want to plug a 5 in there for x. And so just put a 5 in there where x goes, and when you compute it, you get the predicted score for someone who misses 5 class periods. Next, we're asked to compute the residual, and that's going to be what's the difference between what this predicted value was and what we actually saw in our data. And so you're going to have to go look back at the data for someone who missed 5 class periods, and it is 73.7. And so we take the actual value from our data, which is 73.7 here, and we subtract the prediction from our least squared regression line, and that's how you calculate the residual. And it's going to come out to be negative because our actual data is less than or below the least squared regression prediction. And this is the amount that comes out negative. And here where it says, is the final exam score above or below average for this number of absences? So it's saying this data value, is that above or below average? Well, the prediction from the least squared regression line is what the average is what we assume to be the score on average for people missing 5 classes. And so this is below the average, and we can see that from the residual being negative, and also just by comparing the two numbers, we see that our actual data score is less than our predicted score. And then drawing the least squared regression line on the scatter diagram, if you jump back into StatCrunch, you'll notice when you do this regression, if you hit the over arrow, it actually shows the line drawn through the scatter plot. And the answer choices will look a little bit different because here you'll notice the y-axis jumps from 0 all the way up to 65. And so the line is just sloped differently. But you can look at the pattern of where the dots fall above or below the line to compare your results. So looking at the dots, I'll just start down here and go up the line. We have above, and then slightly below, and then the next dot's above, and then below, below. And looking back at our answer choices, you'll see the correct one follows that same pattern. I can make it even bigger. You have above, slightly below, above, below, below. And none of the other answer choices have that same pattern. So this is clearly the correct one. And the last part of the question is asking if we should use this least squares regression line to predict the final exam score for someone who missed 15 class periods. So should we plug a 15 here in for X and use it to predict what their final exam score would be? And if you look at our data, we only looked at students who went from 0 absences to 9. So 15 is beyond the scope of our data. And for that reason, we should not use the least squared regression line that came from this data to plug in a value that's way outside the scope. So no, do not plug 15 in because it's outside the scope of the model. For number 10, we're looking at the relationship between the compensation for a CEO and that company's stock performance. And the key here is that when we analyze the data, we get a correlation coefficient right here. And we had 10 people in our sample, and for a sample of 10, we would want the correlation coefficient to be larger than this. The absolute value here should be larger than this for us to assume that there is a linear relationship between our x and our y variable. And since our correlation coefficient is less, we're going to assume there is no relationship between the x and the y. And when that's the case, what you're supposed to do is just average all the y values from your sample and use the average from your sample as your prediction for every single different value that x could be. We're just going to use the average from our sample. So let's open our data here in StatCrunch and get the average stock return. And to do that, we go to Stat and then Summary Stats of that column. of stock returns, and it'll give us all these results here, and one of them is the mean or the average, so that's what we want when we hit compute. And we get that mean value back, and we wanted that to one decimal place, and no matter what value we have for our X, for how much the CEO makes, our prediction is always going to be the average from our sample. So as X changes, it doesn't change our prediction, and that's because our correlation coefficient was indicating that there's no relationship.